Okay, chain rule. So, chain rule, the top one here is actual chain rule. It says the derivative of a composite function, so a function inside of another function, is the derivative of the outside function, so f prime, times the derivative of the inside function, g prime. We're going to do examples. As soon as you see the examples, it makes a little more sense. The other way, and it's not quite the same, but it's very, very similar, and it's what most people sort of are comfortable with, is if you call the general power rule, and it says if u is some function in terms of x, and y is equal to u to the n, then y prime is it's the power rule. You drop the n down, you take one away from the exponents, that part's the power rule, and then you just have to multiply by whatever the derivative of u is. So u prime, again, outside derivative, inside derivative. So when do you use chain rule or the general power rule? It's for functions that look like this. So if you have y is equal to x squared plus 1 to the power of, I don't know, 10. You could, in theory, multiply that out 10 times and generate the polynomial. That's going to take forever. Probably a high probability you make a mistake somewhere along the lines. But does everybody see there's two functions here? This is sort of the key part. You have to be able to see an outside function and an inside function. What would the outside function be of this? Yeah, it's the power of 10.
Or any variable?
Yeah, it doesn't really matter, but it's the power of 10 is sort of the outside. Okay? This is the outside. Obviously, this is the inside function. All right. The other type that we're going to look at is if you have trig functions. So everything we've done till now is like sine x, cos x. But now we can start doing things like sine 6x. So there's two functions here. What's the outside function? Sine is the outside. And the inside is 6x. It does matter. The outside is the outside. 6x is the angle, right? It's inside of the trig function. So, and then another example would be root 3x plus 1. Did you want to talk to me or are you just ticking?
Is that okay?
No, get out. Close the door on the way out. Don't let it hit you in the bum. You're violent. Violent. Root. What's the outside function here? Yeah, the square root or power of a half, right? Outside function, and then the 3x plus 1 is the inside. Okay. That's your first goal, is recognizing there's an outside and an inside function. And once you do that, then you know you have to use chain rule. So let's practice using chain rule. Okay. F of x is equal to 3x minus 2x squared to the power of 5. Like I said before, if you really wanted to, you could multiply that out 5 times. It's not going to be fun. So we're going to use chain rule or general power rule. General power rule sort of fits a little better.
They're the same thing.
Essentially, yes. Like, I'll show you an example in a sec here. So, f prime. What's the outside function?
5.
Power of 5. Power of 5, right? So the first thing that the power rule says is that exponent falls down in front, just like we did before. So the 5 falls down in front. 3x minus 2x squared. So then we're left, we take one away, so then we have to the power of 4. Okay, that's the derivative of the outside function. Now we multiply by this one, u primed. So what's the derivative of the inside? This is the inside function. Call it u. 3 minus 4x. All right, does that make sense? This is the outside, and this is the inside derivative. Okay? Does that make sense? This is really important. Then you would clean it up. I'm not going to worry about that right now. Okay? Yeah, for now we'll just leave it like that. Let's do another one. Okay. So, what the general power rule allows you is it allows you to get away from quotient rule sometimes. Because nobody really likes quotient rule, it seems like.
I actually am a big fan of it.
Okay, well, except for Matthew. Matthew loves it. So, I can flip up the x squared plus 1 and rewrite it as 3 x squared plus 1 to the negative 2. And now I apply chain rule or power rule, which says that negative 2 falls down. What's 3 negative 2? X squared plus 1. Take away 1, so what do I get? What? Negative 3? Okay. So I take 1 away. Then you have to multiply by the inside derivative. What's the derivative of x squared plus 1? 2x. This is easy to clean up. We can just go 2 and 6 is negative 12x and flip it back down. And that's your derivative. You don't have to use quotient rule, so that saves you a bunch of time.
So how do we just like,
You sure?
Yeah, I'm good.
Okay. Okay, let's do another one. We're not going to simplify it. We're just going to do the first line. All right. So, now we should be able to do it in 2 lines. All right, here we go. So, first of all, I look at this. What do I not like about it? Radicals. You don't want radicals, so you got to write it as a power. So we write it like that. All right. Now we can do the derivative. So f prime of x. Because we have a separation by a subtraction, that means we have 2 terms. We can do each derivative separately, right? So we're going to do the derivative of this one first, which says bring down the 2. What's 2 times 2? 4. So we get 4 x to the 4th plus sine of x. Take away 1, so that's the power of 1. Times, what's the inside derivative of x4 sine x? 4x cubed, and then the derivative of cosine is cosine. So that's the derivative of the first part. Plus, now you gotta do minus. Now you have to do the derivative of the second part. What do I do with the x squared plus 4? What do I do first? Drop the half. X squared plus 4. Take away 1 from a half and you get negative a half. Then you multiply by the inside derivative. What's the inside derivative of x squared plus 4? 2x. What?
Why don't we just solve
Hey, whoa, there's like too many questions coming at me right now. Talia first. What did you ask me, Talia? Okay.
so the radical of x squared plus 4, could you not just like make it x plus 2?
No. That with an addition sign, it doesn't work. You can't just square root each thing. Okay? I'm just going to give you some. Are we okay with that? It's the derivative. Drop the exponent down. Take 1 away from the exponent. So the stuff inside stays the same. That's this part. And then the second part is the derivative of all the inside stuff. Okay? Yeah, you can. Like, we can clean this up. Those 2's will cancel and stuff. But I don't really care about that right now. Okay? We feel okay? 136, 7 to 21 odd. Please. Yeah. All right. Chain rule and trig. So now instead of having just sine x, or actually, what's the derivative of sine x? Let's do that. So derivative of sine is cos. The derivative of cos is negative sine. And the derivative, the derivative of tan is secant squared x. Okay, but if you notice, all of those have just x in for the angle. What if we put a 2 there? So chain rule says derivative of the outside function. The outside function is the trig function. So what's the derivative of sine? So I get cos of the inside stuff times, and then you multiply by the cosine, or the derivative of the inside function, 2x, which is 2. So this is just 2 cos 2x. All right. Cos x squared plus 2x. What's the outside? It's cosine. So if we do the derivative, we do derivative cosine, which is negative sine of all this junk, x squared plus 2x. multiplied by the inside derivative, which is 2x plus 2. Now, normally you would write that in front. That's how it would be written. And you could put the negative in if you wanted. But there you go. Three. Cos of x squared. What's the outside function? Cos. So this is a bit of notation. If the squared is on the x, it means the x is being squared. If I wanted the cosine to be squared, you would either write it like this, like that, or you'd write the squared like that on the cosine, okay? So this means the x is being squared, so the outside function is cosine. So y prime, the derivative of cosine is negative sine x squared times the inside derivative, which is 2x. And then you'd usually move that to the front. And you get that. Anybody know what the derivative is? Cosine of 3 is a constant, right? So you just have to worry about the x squared because it's cosine 3. Like I could put the number in and get a decimal, right? If there's no x, it's just a constant. So you're just doing the derivative of x squared. So this is just y prime is equal to 2x cos of 3. Because you're not deriving cosine of 3. If you put that in your calculator, you're going to get a decimal, right? Yeah, like this is separate, right? If I wrote it like this, if I wrote cos of 3x squared like that all together, then this is inside the trig function. But because it's all just by itself with this multiplication dot, it's separating them and showing you it's cos 3 is just some constant. All right. Isabella. Cosine of 3, like you can put that in your calculator, it's some number. So you don't have to derive that. It's like if I said, do the derivative of 3x squared. You would just drop the 2 down and multiply by 3, right? Well, this number is because it's a constant. Cosine of 3 is some number too. It's a constant. It's not as nice as the 3, but it's like if you put cosine of 3 in your calculator, it's some decimal. I don't know what it is. All right, so it's just a constant, so you don't have to worry about it. We'll come back to it.
Is it like you do like the product rule and it's going to equal 0?
Yeah, if you did the product rule, it would be 0. Yeah.
I remember
Explain it like that. All right, sine squared 2x. What's the outside function? The squared is the outside function because this means this. Does everybody see that there's actually three functions here? There's the outside one, which is 2. Then there's sine, and then inside the sine, there's the 2x. So you start on the outside and you work your way in. So y primed is, drop the 2 down. Sine of 2x, take away 1, so it'd be to the power of 1, which we don't have to write. Times, what's the next function in? Sine. What's the derivative of sine? So then it's cos of 2x. And then what's the next function in after that? 2x. What's the derivative of 2x? Times 2. So then this would clean up to be 4 sine 2x cos 2x.
And order doesn't matter.
No, it doesn't really matter. Usually you put, are you talking about sine and cosine? Yeah, they don't use, it doesn't matter. That's a double angle identity, but we're not going to worry about that. All right, last question. Nope, I lied. Second to last question. Cosine of 3x all squared. What's your outside function? Cosine, because the squared is on the 3x. So, y prime. Derivative of cosine is? Negative sine of 3x all squared times. What's the next function in? It's that squared. So you drop down the 2. I'm going to show you 2 different ways to do this. So drop down the 2 times 3x. I'll write to the power of 1 just to illustrate that it's that. And huh? 2 is inside. It's the derivative of the 3x all squared. Times, what's the derivative of 3x? 3. So then it's 3 times 3 is 9, times 2 is 18. It's like a negative. Hang on. 18x. Y is what? What equals 0? What? Oh, the derivative of x? Is that what you're talking? Yeah, it would just be 1. All right. Three times 3 is 9. 9 times 2 is 18. Are we good? All right. You could have also done this one this way. Squaring the 3 and the x, you would get cos 9x squared, and then do it that way. Derivative of cosine is negative sine 9x squared times the inside derivative, which is 18x. Gives you the same thing. All right, last question. Let's do y is equal to tan cubed 3x all squared. That looks like an 8, so let's make it a 3. There we go. So you could, it probably makes more sense to clear up the 3x squared and write it as 9x squared. Yeah, you're still gonna have a 10 in there. So what's the outside function? The cube. So you drop the 3 down because this means, if I write it this way, it's a little easier to see. It means that. So the 3 falls down in front. And then you get 10. So then it's going to be to the power of 2 of 9x squared times, what's the next function in? Tan, right? We've done that one. Now we have to do the derivative of tan. What's the derivative of tan? Secant squared of 9x squared. So then tan's done. And then what's the final function? Yeah, 9x squared. So you take the derivative of that and you get 18x. So you can see how chain rule takes a simple function and it blows it up into something big. Like simplify this? Oh, derive. Then you've got to use product rule with it because you have functions being multiplied together. We're gonna get to that. That's tomorrow's lesson. And it gets real. Yeah, those get ugly. The only thing I would do is this 18. I would move up there. That's all I would really do. So what's 3 times 18? 30, 54? And that's an X. I would do that, but that's about it. Here's your questions. 136, 43, well, not 443. 43 to 63, odd, 83, and 89. Please, but there's only 5 minutes of class left, so. Oh, just let me turn this off.